So with the previous slide, we are towards the end of sampling methodology, and the second part of my topic will be on statistical analysis and test of significance. Sorry that I could not give any break in the middle because we were given only 45 minutes to 50 minutes to complete the topic, and you know that the topic is more vast than what we try to think about it. So without wasting any further time, into the different statistical tests. So to give an introduction about different statistical tests, statistics is a mathematical science which deals with the methods of collecting, compiling, presenting, interpreting the numerical data, and making inferences or drawing conclusions based on the analysis of data. So it deals with all the process of collecting the data, compiling it, and presenting it in a readable manner, and also to interpret the data which will be understandable by any other person. And also from the data we have collected, we need to make inferences or to find conclusions which will be useful for the population. The uses of statistics in biomedical sciences are three. That includes to find the difference between different groups. Let it be one group, two group, or more than that. In case of one group, we can find the difference between that particular group and the normal value. In case of two and more groups, we can find out the difference between those groups. The second thing is to find the association between the groups, or to find the association between the etiological factor and the disease that is being studied. The third one is to find the time to event data. Basically, statistics can be of two types. You will be very well aware of the different types of statistics and all, but this will just be a prologue of whatever we are going to see, or this will just be a recap so that whatever I am going to talk about test of significance can be of a very good understanding to you. So in descriptive statistics, we will just find out or describe the population in terms of percentage or mean or standard deviation. Whereas in inferential statistics, we will try to generalize the results, whatever we get in our study population, to the whole population or the sampling frame. And also sampling is completely necessary step in the process of inferential. So as I have said you that this will be a prologue, we will just see the different types of data here. Data can be classified basically into qualitative and quantitative data. So qualitative is anything that is not measurable is qualitative, anything that can be measured is quantitative. And this qualitative can be divided further into nominal and ordinal. So nominal is anything that we can nominate a value to is known as nominal. For say race, religion, they doesn't have a particular order. We will just like that nominate some value to those particular things. For say gender, so there is nothing like inferior or superior in terms of gender. We will just like that nominate a value 1 to male and 2 to female. So that becomes a nominal data. Ordinal data, it will already be arranged in an order. For example, pain, it can be arranged from mild, moderate to severe and very severe also. So anything that is already arranged in a particular order is known as ordinal, and for anything that we need to nominate a value and it doesn't have any meaning is known as a nominal. In quantitative data, it can be either divided into discrete and continuous. Discrete is nothing but whole numbers, whereas continuous can be any number with points or decimals in it. For say in discrete, the DMFT scores, it can be 1, 2, 3 till 32. It cannot be 1.2 or 1.3. Whereas continuous variables like mouth opening or distance between two teeth, it can be 1.2 centimeter, 1.5 centimeter, and so on. This continuous can be again divided into two types, which is ratio and interval. Any value that doesn't have a true zero is known as interval. For example, temperature. Temperature does not have a true zero. We consider that boiling point or the freezing point of water as a zero, and then we have given values for the temperature. And temperature can go in negative also, whereas ratio can never go in negative. Height of a person, it will start from centimeters, feet, and inches, whereas it can never be below zero. So these are all basic different classification of data and their classifications. And we already are very familiar with these things like the mean, median, and mode, which are used to represent the measures of central tendency. And then comes the measures of dispersion, which include range, mean deviation, and standard deviation. And then we are also familiar about this particular concept of normalcy curve or the normal distribution, in which the curve follows a symmetrical distribution, and it is following, it is in the shape of a bell. The mean, median, and mode falls in the middle, and all those things. So I'm just trying to give you a recap of whatever you know in the BDA. And now we will enter into the tests of significance. So again, I'll repeat you types of data, the measures of central tendency, dispersion, and normality curve will be again and again helpful for you to decide on which test you are going to choose in your study and so on. Okay, so with this we will go into the tests of significance. Tests of significance are nothing but they are all statistical procedures to draw inferences from the samples about the population. And then why it is basically required? Because we need to study whether there is a significant difference between two different groups or not. Because always it can be said that boost is equal to that of Bonvita, but until we conduct a test of significance to find out whether a boost is giving us more energy or Bonvita is going to give us more energy, it is waste of time. As boost and Bonvita, we can also compare water with boost. Drinking boost is also liquid kind of drinking, and drinking water is also liquid kind of drinking. But until the company proves that drinking boost gives you more energy, it is totally waste for us to spend the money in drinking the boost. So to find out whether there is a significant difference between two groups, we need to conduct a test of significance, and also to find out whether the difference is real, or when can we generalize the results to the population also. This test of significance is helpful. There are basically 5 steps for conducting a test of significance, which includes stating a null hypothesis, choosing the levels of significance, that is the alpha value, which is a constant, always it can be kept to be 0.05. And then the third one is to decide the test of significance. How to decide it we will see in the forthcoming slides. And then to calculate the value of test statistics, that is we will calculate the statistics using different formulas and so on, and then we will represent it in terms of mean, median, and mode, or using uh, standard deviation and interquartile ranges. And finally we will have something known as the p-value, which will help us to tell whether there is a significant difference or not. Okay, now that we have known about different steps in conducting a test of significance, we will see what are all the important assumptions or factors that we need to consider before selecting the different tests of significance. The first one is the type of research question, because the research question will conduct the PICO format, that is population being studied, the interventions, the comparing groups, and also the outcome that is being studied. So that will help us in choosing what kind of tests we are going to use. The second one is the type of data. So we have already seen the different types of data, which includes qualitative and quantitative. So based on the type of data that we have recorded also, the test will be selected. So for any qualitative data, we will go with only a few tests, which includes the chi-square test or Friedman test or the McNemer test. Whereas for quantitative data, we should again do some process, and based on that only we should select the type of test being used. So that is, we need to check for the distribution of the data. So whenever the data is quantitative, we need to check for the distribution, whether it is normally distributed or it is non-normally distributed. So that can be done by doing few tests, which includes the Shapiro-Wilks and Kolmogorov-Smirnov. But the concept is that the test will try to plot all the values in the graph, and if the graph is following a symmetrical distribution with mean, median, and mode at the center, then we will follow the, it is assumed to follow a normal distribution, and we will use a parametric test. Whereas if it is not following the normal distribution, then we will be using the non-parametric test. Then the finally is the number of groups or the data sets that is being involved in the study. So based on the number of groups that are there, we will select the test. So we will see a basic introduction about the parametric test. According to Robson's, a parametric statistical test is a test whose model specifies certain conditions about the parameters of the population from which the sample was drawn. That is, there is an assumption that is being already made in terms of parametric test, and the assumptions are like norms. So the population is assumed to follow all those things. Then we will go for the probability or the parametric test. The parametric test includes Pearson's correlation coefficient test, t-test, z-test, and so this Pearson's correlation test is used to find out the relationship between two variables, whether they are having a positive relationship or whether they are having a negative relationship. This is somewhat similar to that of the inverse relationship or the direct relationship. So here we can see that whenever there is a perfect positive correlation, the value of Pearson's correlation coefficient will be in positive numbers, and whenever there is no relationship, the Pearson's correlation coefficient will be 0, and this is how the graph will appear. And whenever there is a negative correlation, the graph will go or show a downward trend, and the values will be ranging from -1 to 0. So a Pearson's correlation coefficient value can range from -1 to 1 through 0. 0 means there is no relationship between two parameters, and when it goes in positives, then there is a positive relationship, and when it is going negative value, then it means that there is a negative relationship. This can be used to find out the relationship between age and the dental caries status of the population, age and periodontal disease status, or number of cigarettes smoked per day, and the nicotine dependence of the patient. So in these conditions, we can use the correlation coefficient test. The next one is the t-test. So whenever we assume that there are more than 30 samples, then it might follow a normal distribution, and then we go for the t-test. And also we should check using the test also. Instead of assuming, we can go with the normality test and then confirm whether the data is quantitative and it is following a normal distribution as well. There are two different types of t-test. The first one is a paired t-test, the other one is known as the unpaired or the independent t-test. So whenever there is whenever we need to compare between a single group before and after the treatment, we can go with the paired t-test. So there will be a single follow-up and the baseline data that is available for us to compare the data. And in case of unpaired t-test, we can compare the data of two completely independent groups. So few examples for or conditions where we can use the unpaired t-test are to compare the height of boys and girls, because boys and girls, so the height of one parameter does not have any relationship with the other parameter. So to compare between boys and girls, we can go with the unpaired or independent t-test. And in terms of using two different methods to for stress reduction, we can use the unpaired t-test. The second commonly or the third most commonly used test is the one-way ANOVA analysis of covariance. So this is almost similar to that of the t-test, but we will use this ANOVA when we have more than two groups. For example, when we need to compare the effectiveness of herbal, homeopathic, and fluoride toothpaste in preventing dental caries, we can go with the ANOVA. And then instead of using a paired t-test, when we are having more than two follow-ups, that is baseline, first follow-up, and then when we have the second follow-up, we will go for something known as the repeated measures ANOVA. So these are all the basic tests which is considered to be the parametric test. The second part is the non-parametric test. So to have a basic introduction about the non-parametric test, we have few criteria, that is, if the sample size is less than 30, we can go for non-parametric test. If we run a normality test and the normality is being shown as that the distribution is non-normal, then we will go with the non-parametric test. And if we have used a non-probability sampling method, we will go with the non-parametric test. So the sampling methodology, the sample size, as well as the distribution of the data can help us to choose whether we need to go with the non-probability sampling tests or not. But the problem here is that it requires more data for us to conduct a non-probability sampling method, and it is also less efficient when compared to that of any probability sampling method. So there are different tests. Unlike the probability sampling method tests, the non-probability sampling tests are named after each and every person. So it might be a bit difficult initially for us to remember the name of the test, but as and when time goes on, you will automatically keep remembering it, and then you can use it as well. So the most commonly used test is the chi-square test, and then other tests that are used are McNeema test, Wilcoxon sign rank test, Mann-Whitney U test, Kruskal-Wallis, and so chi-square test is being invented by Carl Pearson, and it is the most common or simplest non-parametric test that is being used, and this is the formula that is being used to calculate. So chi-square test can be used for three different purposes. One is to test the association, that is to find out the association between two factors, which can be smoking and cancer, treatment and the outcome of the disease, vaccination and immunity. It can be used to compare the proportions between two different groups, that is to compare the frequencies of diabetes and non-diabetes in groups weighing between. So based on weight whether people are diabetic or not. So to compare between those things, we can use a chi-square test, and finally to find out the goodness of it. The other test is known as the Fisher's exact test. So this is similar to that of chi-square test, but whenever the sample size is less than 20, then we will go with the Fisher's exact test. And more than 20, if more than 25% of the cells in your chi-square test or the 2 into 2 table that you derive as a frequency of less than 5, then we will go with the Fisher's exact. Then comes something known as the McNeema test. It is used to compare between before and after findings in the same group. So it is also it is something similar to that of a PAT-T test, but here we will use it for a non-parametric purpose as well as for the qualitative data. So example here is comparing the attitude of medical students towards confidence in statistics. Analysis can be done before the session and after the session, where you can give your confidence level into very confident, confident, or slightly confident, or not confident. So they are all a ordinal data, and before and after comparison we will be using the mix. The next one is known as the Wilcoxon sign rank test, which is the exact non-parametric equivalent of the PAT-T test. Even for a quantitative data, when it is not following the rules of or when it is not normally distributed, we will go with the Wilcoxon sign rank test. We will compare with baseline and the follow period. Mann-Whitney U test, it is the exact replica of the independent or the unpaired t-test, wherein we can compare between the two groups and then we can tell whether there is a difference existing between the two groups or. Then comes the Kruskal-Wallis test, which is exact replacement of the ANOVA test, wherein for any quantitative data that does not follow normal distribution, we will follow the Kruskal-Wallis test. And it is also an extension of the Mann-Whitney U test. In Mann-Whitney U test, we will have only two groups. This is an extension wherein the group numbers will be more than 2. Then comes something known as the Friedman test. Friedman test is equal to the repeated measures ANOVA, in which we will have more than 2 follow-ups. Example, baseline, follow-up 1 in 14 days and follow-up 2 28 days. Then we have something known as Spearman's correlation coefficient, which is again a non-parametric version of the Pearson's correlation. The value here also lies between -1 to +1 through 0. 0 means there is no relationship between two variables, and when the variables are in positive signs, then it means that there is a positive relationship, and whenever it is in negative, it means like there is a negative relationship. Here we will have a chart which will help us to identify or to spot out what test we can use at what time. So we need to first of all identify what kind of data we have collected. So if it is a qualitative data and only we have two different groups, we can go for chi-square test or Fisher's exact test. So chi-square test is the most commonly used test, but when we have a sample size even less than 20, and if we see that the cell frequency is like 25% of the cells have a frequency of less than 5, we can go with the Fisher's exact test. Whereas when we have pad data, that is before and after data, we will go with the McNeema test. So these tests can be used for only qualitative. And when it comes to quantitative data, we need to check for the normalcy of the data. So the first step for assessing a quantitative data is that we will check for the normal distribution, whether it is normally distributed or non-normally distributed. In case if it is normally distributed, when there are two independent groups, we will go with the unpaired t-test or the independent t-test. and if it is more than 2 groups, we will go with one-way ANOVA. If it is a paired group, that is before and after treatment, then if it is only a before and after, we will go with paired t-test. If we have more follow-ups, then we will go with repeated measures ANOVA. If the data follows a non-normal distribution, in case of 2 independent groups, we will use a Mann-Whitney test, and if there are more than 2 independent groups, we will go for Kruskal-Wallis test. In case of paired data, before and after, we will use a Wilcoxon-Signed test. If we have more than 2 follow-ups, then we will go with Friedman's test. So with this, we can conclude this particular topic, that is, it is essential for us as medical researchers to know about statistics and different statistical tests and when to use what test, and also it helps us to provide generalizations to the population, because whenever we need to publish an article, the first thing that the reviewer will see is that whether we can generalize our results, that is to India or towards the world population. So if we cannot generalize it, then they will ask us to go with publishing in a local journal. So to generalize the results, definitely we should have a proper idea about the statistical test, and also it will help us to critically evaluate whether other articles or other treatment modalities can be incorporated or not incorporated, and it will also provide us information about the methodology of the research design, whether it is valid or not valid. If they have used inappropriate test, then we cannot completely rely on the data that they have given us, and we cannot implicate, or we cannot mention those results, or we cannot use those results in treating our patients. These are all the few references which I have